the security policy in web applications. And then I will discuss 4 topics where we actually will see that the state of practice actually advanced quite a lot in the past 2-3 years to actually make this server-driven security configuration actually possible. So we saw already quite some talks on web security, so the basic technology of how HTTP cookies and all the rest is working. I will not repeat this in this talk. I don't think we need to focus on that. One topic I wanted to pick out is the working of the same origin policy, because the basic security policy for the web already since the 90s is the same origin policy, and we need to understand what is the impact of the same origin policy on scripts and frames to understand how certain techniques are taking advantage of that. We have 2 basic composition technologies if you want to include content from a third party or from an untrusted source even within your own domain. The first one is script inclusion. It means that you actually can load scripts from third parties as if you have written them yourself. And what it means from a security point of view is you're actually loading the resource from the third party in your application, but for the web browser it doesn't differentiate between external scripts and your own scripts. It's just running as if you wrote the JavaScript yourself. It's running in your security context. It has full access to the DOM, to cookies, to local storage. It can do anything your own application can do as well. So there's no security enforcement, there's no security boundary. You're just taking the third-party resource and running and executing it as if it was your own resource. The other technique to include third-party content is iframe integration, and it means that you actually will put a separate almost window as part of your original website, an additional frame, and that frame loads content from a third party. This has a whole different technology in looking towards security enforcement, because the original page, the outer page, will run in the security context of your own website, but the third-party content will run in its own security context of that third-party domain. So we have a strict security sandbox between the two. You have a strict security separation. The third-party content can still do all the sensitive operations at once, but they will execute in the domain of the third party. So you can only look to the cookies of the third party, it can do storage in the third party, it can contact back to the server of that third party domain. If you're looking to what is used on the web, 2 years ago I would say almost anyone is using script inclusion. So all the things that you include from third party reside to be script inclusion. We see a trend, for instance in Facebook, but also in other integration networks, that they are actually using the sandboxed attribute to make sure that there's a by default separation between content of a third party and their own content, and that they're using interaction mechanisms like web messaging to interact between the yellow context and the blue context. So we see a shift from this towards this, but this is only a minority. Nick will go much further in discussing this, but script inclusions, we can easily say that almost 90-95% of all the websites are including scripts from a third party. Okay, this is enough for basic context. We know the security policy, the same origin policy, and that will be enough to understand all the rest of the talk. The first topic I want to actually touch is how we can secure the browser-server communication. And the 2 attacks I will discuss here are session hijacking and SSL stripping, and I will discuss a number of countermeasures in increasing complexity or in increasing protection that they will offer towards secure communication between the browser and the server. So the first attack, session hijacking, will not be new. We already touched on that in the talk of Jim Manico. The idea is that you have between the web browser and the web server some attacker that has control of the network, and it can be a passive network attacker, namely he can just eavesdrop on the network. That's very easy to achieve. Any wireless almost, you can easily eavesdrop what's going on, and you can actually see any packets passing by without interrupting or without being visible. So what happens if you're using session management between the two? The web browser is sending an HTTP request to the web server, attaching the cookie with the session ID. The eavesdropper, the attacker, sees that this cookie is passing by. It's actually setting up a new session to the web server, reusing the same session identifier, and from that moment on, well, you can just take over the session and execute all the operations you want in a separate browsing environment. You don't need to control the browser of the client anymore. This is well known to attackers, but still a lot of websites are vulnerable to this attack. Think about the Firesheep extension a few years ago to actually sniff all the passwords of social networks, Gmail and the like. We see a trend that some of the larger websites are moving towards countermeasures, but still if you would sniff during SecAppDev, I'm pretty sure that you would have a lot of passwords sniffed just purely by session hijacking. Okay, we already saw a lot of talks touching on HTTPS. It's an obvious choice. If you want to protect your website against this, you're starting to put HTTPS on that. So you're actually tunneling or encrypting the channel between the web browser and the web server. And by doing so, because you have confidentiality, the attacker, the network attacker, can't see your session identifiers anymore and you're protected. Quite obvious, but the question is the problem cured? Well, if you're looking to the survey made by Qualys in 2010, the use of SSL TLS is quite low. They actually monitored and they scanned all the domains on the internet to see whether they have HTTP port, HTTPS port open. They were also controlling if they had a valid SSL certificate, and it turned out that only less than 1% of all the active domains had TLS enabled with a valid certificate. We have to be honest, these are with valid certificates. The numbers are a little bit higher with self-signed certificates, but we can't assess in the wild whether those self-signed certificates actually make sense or not. It could be, for instance, organizations have their own CA actually signing their certificates so that people browsing externally can't assure that it's valid or not valid, but that for that company it's a good solution. Also, a lot of the devices that are scanned on the network might not be a web server, might be your NAS connected to your home router or anything else. Anything that communicates HTTP was included in this survey. If they were looking to the top 1 million domains recorded by Alexa, so the most popular domains which were visited by users having the Alexa toolbar in their browser, it turns out that around 27% were using TLS. So the rate is much higher if you're looking to the most important websites or the most frequently used websites. But even if you're using TLS, I will show you in the next slides that there are still some remaining problems, namely in using HTTP and HTTPS in combination and hybrid setup, and also with SSL stripping. So first, what is the mixed use of HTTPS and HTTP? Well, you will notice a lot of websites you're visiting, you're starting with HTTP, you're going to HTTPS to actually enter your password, you're having a secure session on all the things that are changing session state or changing your profile, and it was already discussed in previous sessions as well. That might be a good cure, but you have to make sure that you're protecting your session identifiers in a good way. By default, all those cookies that are set on HTTPS are also transported over HTTP. What's the impact of that? Any packet over HTTP, any request over HTTP will leak your session cookies or the whole set of cookies. So it means that you have to make sure that if you're using a hybrid setup, that you secure them. And how can you secure them? Well, quite easily. There's a specific flag for cookies, namely the secure flag. If you're including the secure flag on the issuing of a cookie in the HTTP response, then the browser knows that that cookie can only be sent over an encrypted channel. So then you can have two session cookies, one for the HTTP session, one for the HTTPS session, but by now you know that your HTTPS cookie will never be sent in the wild.
So can you set these attributes on an HTTP response?
So indeed, so in the HTTP response, the server issues a new cookie, and while saying this cookie has this value, domain, and even path and expiration date, you can also add the flag secure, and if the flag secure is added, then the browser knows that he has to treat it as a secure cookie, meaning that it never should be sent over HTTP.
But isn't it too late by then to set that flag or set that attribute because it's traveled across?
Yeah, sorry. In my presentation, I don't make any distinction between HTTP, HTTPS. Of course, this should be sent over HTTPS. I just wanted to say HTTP, the format of the request is HTTP request response, but of course this is sent over an encrypted channel. Also in the rest of my slides, let's assume that by default we have to read it as HTTPS because I think it's a good enabler to protect your website by running it over HTTPS. Apart from problems we discussed earlier with performance and caching, but I think this should be the default behavior. Okay.
Even on the previous slide you mentioned that cookies are tied to domains, not origins.
Yeah.
So what's the
okay. Indeed, I didn't discuss that. A domain is just google.com, and with domains in a web browsing security context, we typically have the topmost domain name, so we don't have the subdomains included. We typically discuss google.com, facebook.com, kleuven.be. With origin we mean actually scheme, domain and port. So it's HTTPS, facebook.com and port 80, and that triplet is actually an origin. And if would cookies have been bound to origins, we didn't have the problem because the scheme would have been different for HTTP, HTTPS, but cookies are bound to domains. But it's interesting because we will later on also see how origins are specified in one of the techniques. Okay, so secure flag, actually I assumed that most of you were already aware of the secure flag. I just wanted to have it as a reminder. You just have to enable it by default for your session cookies. I don't see any good reason why session cookies should be sent over HTTPS and HTTP and being the same. Because then you're actually mitigating the technique of having HTTPS in place.
So it's a browser that enforces that?
Yeah, your browser is actually enforcing that, and all modern browsers are doing that correctly. What I also wanted to do is actually, for each of the technologies I'm discussing today, seeing what is the state of practice. Just to give you some advice, some insights. In all technologies being used, what is the adoption rate? And also, in a second statistic, what is the compatibility of the browsers? How well do browsers support this new technology? So the secure flag is already some old technology, so you see all the recent browsers all supporting the secure flag. If we're looking to usage statistics, we did a small experiment, and I will focus on the next slide how we did the experiment. What the takeaway is, well, we visited the most popular websites visited from Belgium, and only 22% of those were actually issuing a secure flag on their cookies, or at least one secure flag on one cookie in all the pages that we were visiting. And you see, most of those domains are actually international domains that were visited from Belgium. You only see, I think, one local domain specific tied to Belgium.
So you mean here that the secure flag is on in an HTTPS session?
So I will focus on the next slide. What is the data that we're using for that? So we did a small experiment. We only set it up like 2 weeks ago, and one of my PhD students is actually triggering that experiment. We inspected for this slide like 100 domains, but only 96 of them were responding. We already increased the experiment to 1,000, and we are increasing even further, but all the sites today discuss about those 96 domains. We wanted to visit 500 pages on each domain. How we did that? We actually searched in the search engines what are the top 500 pages listed for that domain. And you will see some of the domains have 500 pages, but some of them only have like 50 or 200, 400 pages that are visible in a search engine. So this means that we didn't visit 50,000, but we visited 44,000 pages on the web. On average, a domain had 462 pages in the search engine catalyzed and that we were able to visit. And only 36 of the 96 domains were also reachable over HTTPS. Also important, it doesn't mean that all the pages were being able to visit over HTTPS, so it could be that only a subset of them were accessible over HTTPS. So this is the number of HTTP pages per domain that we were able to visit. So a lot of those domains only have like a few pages, between 0 and 10 pages on HTTPS. There are that actually serving everything over HTTPS. So we're looking back to the data on the previous slide. So the 22% is actually 22% of the 36 domains running HTTPS actually having the secure flag enabled. And I'm discussing this because we will actually having the same statistics for each of the features I will discuss today.
So does it necessarily mean that if they don't set the secure flag that they would be insecure? I can imagine they might use other techniques like avoiding cookies and using something else. So one thing that we could say, some of the domains that are using, for instance, only HTTPS might be not vulnerable for this technique.
And we will also see techniques where you actually can enforce the browser never to go over HTTP for a certain domain. And for those I could say that might be good enough that they don't have the secret flag. Well, the one that is using this technology is Twitter, and T.co is also a redirector of Twitter. They're actually using the secret flag as well. So I wouldn't make the statement that you shouldn't use the secret flag. It doesn't hurt you to by putting it into your response, and really gives you a good protection level, a first level of protection. So if someone in the audience is disagreeing, having additional questions, please feel free to interrupt. The slides will be online anyway on the SecUpDev website, so you only can see a subset of the material. I don't care. I want you to interact and to understand well what I want to present today. Okay, so we had some background on the experiment. We have the secret flag. This is just the warming up exercise. We have HTTPS and the secret flag. Let's now visit some of the other problems that are happening. One of the things is actually we need to bootstrap the whole thing. If you're going to an HTTPS website, typically what you do is first issuing an HTTP request to the website. The website is issuing a redirect to HTTPS, and from then on you're using an encrypted channel. This is certainly the case if you're browsing with mobile devices. How many of you are using an iPad or even your phone and entering HTTPS : // You just enter your domain name, and from then on you're going further. Well, this is actually an interesting pattern that is attackable, and that was attacked in 2009. Maybe a little bit background for people that want to know how to redirect. Well, you typically do it via a response and a location header, but there are other techniques in JavaScript or HTML to redirect as well, but we don't go any deeper on that. There's one redirection step from HTTP to HTTPS. So the SSL stripping attack, explained by Moxie Marlinspike in 2009 on Black Hat. So again, we have an attacker on the network, for instance, close to the browsing environment. But this attacker has more capabilities. It's an active network attacker. It can handle as a man in the middle. There are several ways to actually achieve those capabilities. Think about putting up a fake access point somewhere here at SecUpDev. Actually, I put it up a Wi-Fi in the other room, so I might have been an attacker there as well. You can even do it with all techniques as well. So one is R poisoning, actually redirecting all the traffic to your own and then pushing it further on. So, but you need some kind of man in the middle to actually intercept and adapt and tamper with the responses being sent back. So the idea is the web browser is sending to the web server. It's intercepted by our attacker. The attacker sends it as is to the web server. The web server says, oh, I want to talk about over HTTPS. But the attacker doesn't pass that on to the web browser. It just is starting to communicate with the web browser over HTTP. And from then on, all the traffic between the web browser and the attacker happen over HTTP, but the attacker itself reflects that over an HTTPS channel to the web server. So for the web server, he's unable to detect that yet the endpoint is not using HTTP. He only sees HTTPS traffic coming in to the web server, but from here the attacker has full access to session cookies, credentials, and all the alike. This is an important attack, and in the technology we had a few years ago, we were not able to protect against that. But luckily there are now new techniques in the browser to easily protect against this type of attack. And it's called the strict transport security. And it's issued again as a response header with the HTTPS response, if I say that. So what you do is, in the communication with your client, you're actually saying, next time you come to my website, don't start over HTTP, directly connect me with HTTPS. And you give a lifetime, a max age, and from that on, the browser is instructed to visit that certain domain only over HTTPS. It will never issue again over the channel an HTTP request to that domain. Of course, you have to make sure that the max age is high enough, but also you must install a max age because there might be some point in time that you have to fall back to HTTP for one reason or the other. So there's a kind of fallback mechanism. You have to renew it from time to time if you want to continue to use this. What's also interesting is that you can use this for subdomains as well. So optionally you could also give the directive include subdomains, and then all the subdomains of your domain are protected as well with this technology.
So does it then only protect the second time that you...
Yep. So there's still a bootstrapping problem. You need to be able to contact your server once before you're actually being protected by HSTS. Luckily, there are clever people in the browser community as well, so they actually populate Firefox and Chrome with a precompiled list of domains that you should visit with strict transport security. The list of domains is still growing. They do some kind of verification, but Google compiled such a first list and Firefox took over that list as well. So if you're going to Twitter, if you're going to certain domains of Google, you will by default be protected with this technology. Which is actually nice because the bootstrapping problem stays an important factor of actually attacking it.
But it's only if you are redirected,
if you're directly contacting
HTTPS, then
that will be fine as well. So for your company website, once you instructed your browser to go to HTTPS on your server and you're issuing this response header, you should be protected by this kind of attack. So again, let's see how many of them are protecting in the wild. We see again that around 22% are protecting. Twitter is really the pusher in this technology, which is also proposing. Sorry.
Is it per domain? That's the address set or per web page?
Per domain. So you really want to protect your whole domain. If you're running SSL, people installing this kind of features typically run the whole website over HTTPS. But that's a good question. Actually, those statistics will give you more insight on that. You're protected for the full domain, but it doesn't mean that any page on that domain will issue the header. So for instance, Twitter was one of the pushers in this technology, also actually defining the spec around this. They're using it on all 500 pages that we visit during the experiment. We also see that all the websites are using it less frequently, like 7% or even less than 1% of the pages issuing the header. So probably some of them are still experimenting, or some of them are only on one entry page protecting their website.
Do you think we can really use it because it's not supported by the
I think it's not at this moment supported, but there might be an extension in Internet Explorer 11, for instance, actually taking that up. So the technology is quite new. It's only like 1 year old, and I think in the next cycle we might expect this to happen as well. We see for most of the technologies today, not all the browsers will support it, but my expectation is that for most of the technology that we discussed today, within 2 years, all the mainstream browsers will actually protect you against that.
But I guess that if a browser doesn't support this header, then too bad. It's just going to drop it.
Yeah, it's just ignored. So that's also the mechanism of using header. If you don't understand the header, you just don't process it, but you fall back to the original scenario. So you're still vulnerable to the SSL stripping attack, but the ones that you can protect are also protected against the attack as well. Okay, we have now a session over HTTPS. We guarantee next time that we'll be connecting over HTTPS as well. Well, we saw already in the slides of Bart yesterday, what about the CAs? We really trust a whole set of CAs in the browser. Some of them might be in some way government controlled. Some of them might just be sending out fraudulent or be very vulnerable. What can we do against that? And this is technology that is still in its early days, but it actually tries to make sure that the certificates you have on your server are also the only ones that are actually representing your domain. So what the public key pinning technology tries to do is actually saying, I fingerprint my certificate I'm using on my server, I'm storing this on the client side, and anytime that browser in the lifespan of this header is visiting my page, it should always see the same certificate or at least some element from my certificate chain. It could be that you issue only a fingerprint of the CA itself or one of the intermediate steps, but you could say I pin my certificates always to be actually include that fingerprint in the whole chain of certificate. Important, of course, is that you also need a second backup fingerprint, because if your first certificate gets revoked, then you have a big problem. So typically in the spec they are actually pushing that you're using a first certificate in production, that you have a backup certificate securely stored that you're not using actively, but in case that your first certificates get revoked or as being compromised, that you can actually use your second to actually still have traffic coming to your website. But this technology is still in early days of actually getting shaped. But I think it might be an interesting way of actually saying, well, the whole CA problem can be reduced For instance, Facebook.com can say anyone visiting Facebook.com is only visiting by the CA that we have chosen with Facebook. And all the other CAs, all the other 60 CAs in your browser, if they're issuing something for Facebook.com, well, you just ignore. Again, there's a bootstrapping problem because you need to push this the first time to your client, but we see quite some traction that people are interested because of the recent problems with the CAs in the last 2-3 years. It's an internet draft, so it's really in the early stages, but it's now supported already in the latest version of Chrome. So they're really trying to push this as the next step, protecting the client-server communication.
So then you actually bind the certificate or the fingerprint, then basically you don't need a CA. You can basically, if you have your own, if you sign your own certificate.
Yeah, but then you have the problem that browsers at this moment are very interrupted. If you have a self-signed certificate, like in Firefox, I think it takes 5 or 6 steps to really visit that website. So I think people will still issue a certificate from a CA already installed in the browser, but they will just reduce the attack surface by saying only this part of certificate chain will be allowed from our website for a certain period of time. To be honest, the examples I saw all have a very short lifetime. So it could be that it's also not practical to actually having a longer lifetime because your certificate might be updated because you have multiple domains in the same certificate and so on. But I think this is technology that still needs to be proven its effectiveness, but it might be an interesting idea as a next step in protecting the communication. So, quick recap of the interaction between browser and server. We saw TLS, the cookies flag, the secure transport security header, and the pinning. I think these are all increasing steps to protect the communication between client and server. And before I continue, I just want to make sure that everyone is on the same page with this. Don't have any remaining questions, because now we're going to a completely different topic. Okay? So what's the next topic? So I want to actually look into script injection attacks, or the cross-site scripting, or the JavaScript inclusion of injection, or what Jim wants to call it. Here we want to see we have a lot of techniques against cross-site scripting. On the server side, we have the output encoding, we have input and output validation, we have all kinds of techniques. But can we have one step further and actually protecting it as an additional line of defense against cross-site scripting, because it's actually becoming one of the main problems in websites. It's very easy to make one mistake on your page, and once you have JavaScript execution in an environment, you can do a lot of harm. You can actually mitigate a lot of the techniques used to protect your website as well. So we will see 3 countermeasures in increasing complexity, and there's only one attack, namely the cross-site scripting. I will just, by means of illustration, show you the start XSS again. We already saw it on previous slides, you saw it on previous talks. The idea is you have some payload being sent to the server. The victim is downloading the payload by visiting an interesting link, a forum, whatever, but the payload gets executed in the origin of the website he's visiting, and at that moment you can steal cookies, you can send new requests to the website, you can read cross-site request forgery tokens, you can do the whole shebang on that domain. The first one is actually not protecting, but it's actually mitigating the risk of a cross-site scripting attack, and it's the HTTP only cookie. So the system is very similar to the secure flag we had previously for securing your cookies over an encrypted channel. Here the HTTP only flag actually indicates that the cookie only should be used in communication between your browser and your server, but should not be accessible by your DOM environment. So JavaScript should not be able to read out your cookie, should not be able to update your cookie. It's only used by the browser infrastructure, communication infrastructure, to send a request to the server. This actually mitigates the impact on session cookies of cross-site scripting, because you can't hijack a cookie, you can't fixate a cookie once there is already an HTTP only cookie in place in your browser. Again, good advice, if you have a session cookie, please enable HTTP only by default. I really don't see good ways why you need a JavaScript having access to your session cookie or setting session cookies. We saw some of the cases where we saw different domains collaborating together, passing by cookies, by actually reading out the session cookie, passing it on. I think it would be a much better idea to actually pass on a token, and then the server-to-server communication is replacing that with a new session cookie for the second domain. But that were the issues. So if you're just blocking all the session cookies available by HTTP only, we saw that some websites were broken because they were using JavaScript to pass on the session cookies with related domains. What is the state of practice? Well, it's supported in all browsers apart from some of the older Androids. I think in 4.0 it was entered as well. But the usage statistics, half of the domains are using the HTTP only cookie, and I think it's already a good sign. It gets traction, and we should use it by default for our session cookies. So one thing I want to say about session cookies, also the secret flag. When we did the experiment, we were not sure that there were actually session cookies installed on the client side. So you could have websites that you're actually crawling with the web crawl, that you only see pages that are not issuing any cookie unless you are logging in and at that moment are issuing a cookie. So that's one of the caveats I want to say with all the statistics here. It could be that more domains are protected, but that we just didn't see the sensitive parts of that website. So very basic technology. The next step is actually a default technology that is enabled by default. If that was the earlier question, this is the XSS protection header. The XSS protection is actually a mechanism already in place in the browser, but it allows website developers to control to what extent the protection should be on or off. But by default, if you don't send anything to your browser, the protection will be on in your browser. And what does it do? It tries to protect against reflected cross-site scripting. It means if it sees a string in the URL and sees that string being executed as part of your page, it will actually try to block that execution. Important to say about the completeness of the protection, it's not foolproof. It tries to protect in the best effort against reflected cross-site scripting, but we saw multiple bypasses being reported in the past few years. But it's an additional step, a little bit raising the bar again. So the default, I want to insert an alert on a forum with a reflected cross-site scripting, typically we will be catched by this technology. So where is this technology being deployed? In Internet Explorer, Safari, and Chrome. But the problem is some of the websites actually suffer from this technology being enabled by default, and therefore they actually made a mechanism to control whether you should actually have that protection on or off. So you can control it with the header XSS protection by setting it to 1 or to 0 if you want to optionally out. If you don't send anything, it's equivalent to actually setting it to 1. There's one additional mode, the blocking mode, which means instead of actually rendering the script execution useless, you could also block the whole rendering of the page and displaying to the end user that there might be harmless and harmful script as part of the website itself, and that's typically what Internet Explorer is doing in blocking mode. So from Internet Explorer 8 on Chrome and Safari, I think it's called XSS Auditor in the letter 2 in WebKit. We see 1/4 of the websites actually using this technology by configuring. Here it doesn't give you an indication of how well they are protected, so the unprotected protected is not purely correct. It actually means they're already taking it into account, but it's the browser that decides, I want to push this technology or I don't push this technology. So you see the difference? Sorry.
So protected in this context means that the flag is explicitly, the header is explicitly.
Yeah. So and I don't have the data here on the slides, but I only saw I think one case where it was disabled, and all of them were actually specifying 1, or actually specifying 1 and the block mode. So it's not that they are disabling the protection, but rather actually explicitly saying, I want to have this protection. So it might also be legacy, I'm not aware of that. It could be that, for instance, the first version of Internet Explorer did not turn it on by default, and only in the second iteration it put it on by default, but people are sending out this header.
With respect to browser compatibility, in one of the previous slides you said it was only on the latest version of Android. So if you mention here Safari, does it both include Safari on OS X and iOS? Or?
I think so, because they're actually implementing this XSS auditor as part of WebKit. But to be honest, for also all the browser compatibility, the moment I'm actually presenting the slides, the information might be outdated. There are good websites actually for each of those technologies rendering on a very, very frequent base what is actually protected in which, or what is supported in which browser. So if you want to know that, I would actually try to refer you to that. We can do it also during the break. There are good websites actually indicating what version of each of the operating systems is actually supporting this. Okay, this is all basic. Now I really want to go to the core of the presentation. Jim already announced it during the keynote, announced it yesterday. It's about the content security policy. And I think this might be the most promising technique of actually protecting against cross-site scripting as an additional layer without touching any of the code on your web application. With a small caveat, but we'll discuss that later. What is the idea? As a website, you're actually on a per page basis, you're issuing a response header that says what is the security policy for that specific website. And this security policy describes which external resource or which resources are allowed to be loaded as part of your page. And we will discuss a little bit later on what are the different types of resources. But I think for what I have in mind, we mainly focus on which scripts and which frames can we actually include in a web application. So I already said it's very promising, and we will see also that it actually is an enabler later on for actually making a good security architecture by using this technology. How do we actually set up the policy? So the policy here might be a little bit obfuscating, but here the policy itself to say, well, you're only allowed to load scripts from your own origin, and you should not have any plugin installed in your browser. This is just very short what this policy means. But we'll go in a little bit more detail how you can actually set up the directives of CSP. In this talk I only will discuss CSP version 1.0. This is the one that is being drafted, that is being actually pushed towards a standard. They're already working very hard on version 1.1 as well, pushing additional features. And it's my personal feeling that a lot of people, and especially for instance Adam Bart of Google, is actually pushing very hard to absorb even the features I'm discussing in other parts of my presentation as being part of the content security policy. That is really the default policy you push from your server to the browser, protecting against all kinds of attacks that I can protect in this way. The main directive is a default source. Anything you don't specify in the header can be specified by the default source. And as values, it actually takes a source list, and we will see a few examples of the source list. And it defaults for all the resources unless explicitly overridden by specific directives. And it mentions which resources are allowed to be loaded as part of your page. And loaded I mean being fetched and rendered in your page. The source list itself can say, well, self, which means the website itself. None if you don't want to have any being included, even not from your own website. And origins can be presented in different ways. So we had already the scheme, domain and port. So this is the traditional representation of an origin. You can omit a port. You can use IP addresses. You could have wildcards for subdomains. You could have also wildcards for the scheme. And you could even say, I only want to specify the scheme, which might be an interesting enabler that we will see later on, to say, I only want to have secure content being included in my page.
But what if you use an IP address? Does that mean all the websites that are hosted at that IP address? Or?
I think that are specified with that IP address. I don't think it's hosted on the IP address. But to be honestly, I didn't see any mentioning of that in the specification, but I should look it up again. But in my interpretation, it was if you specify directly an IP address, then that resource will be fetched. It will not do the check by DNS lookup and then look to the IP address, I think. Also important, and Nick and Steven will talk much more about that, IP addresses might not be such a good idea. And especially what we see in the wild is they're using 127.0.0.1, and that's quite easy to generate on your own PC, for instance. Or they're using an internal network IP address, which is also quite easy to generate, certainly on, for instance, public Wi-Fi and so on. Personally, I'm not such a big fan of using IP addresses, especially if you're deploying your website in a testing environment and there you need IP addresses because you don't have resource or you need local machines to load in NetBeans or whatever. Make sure that it doesn't be pushed to the production environment, because it really can hurt you. Attackers can really use that attack. But more of that in the talk of Steven and Nick later this evening. I won't discuss the whole set of directives. I just wanted to include them in the presentation so that you have kind of reference and so that we have an idea of what kind of resources we can protect with CSP. import or the scripts that we can say which JavaScripts are allowed to be included on our page and being executed. Objects, or actually the whole subset of objects, and, which are mainly, for instance, the Flash or the Java plugins being enabled in your application. You have also style sheets, and we didn't hear anything about this in the previous talks, but if you're talking about script injection, disabling JavaScript is not protecting you completely. There is interesting work of Mario Heiderich, which actually goes on scriptless attacks. With XSS, with style sheets, CSS, you can do very similar things as executing a whole environment. I think the people of W3C even say with CSS they have now a Turing complete machine, so they can actually execute whatever they want in the CSS. Interesting thoughts, but we don't go in any deeper in this talk. What you also can specify is where images are being loaded from, audio and video, frames, fonts, web fonts that you can use, and the connect is actually a bundle of all the ways where you actually are interacting over the web, over the network. So XML HTTP request is the basic one we have in mind, but also WebSockets follow the same directive of connect source. So this is the only one that is not actually including, but that is actually discussing about outgoing requests. Actually, this is what to which origin are you allowed to connect, rather than which of the origins can connect to you or push resources to your website. One optional thing is sandbox. I included here to mention it because it actually will trigger all the technologies that we'll discuss later on with frames, which is actually using the sandbox attribute in HTML5 for iframes. So you can specify it with CSP to actually enable the sandbox attribute on the iframes you are including. One problem with CSP, and problem is not the correct word, one interesting side effect of CSP, in order to operate, it needs websites to behave. And what do we mean with behave? Well, we have two steps. The first step is we should not allow any inline JavaScript or CSS. So all the JavaScript needs to be externalized. All the style directives needs to be externalized in style sheet and style files. It has the big advantage of having a real clean separation between code, rendering directives, and the data itself being in the HTML. The side effect is it's very hard to refactor existing applications. Think about your application of about 100,000 line of code and HTML being all wrapped together. Try to externalize all your JavaScript. So it might not be that easy to do, but I think, and Jim also mentioned it already on the first day of the second theory, I think it might be a very good way of actually enforcing it on all the newly developed applications, apart from using CSP, because it actually gives you the good separation between what is code, what is not executable. So this is one of the things that actually might slow down the adoption of CSP. The second one is you're not allowed to use eval. And the reason for that is if you're using eval, any string, even on the pages that do not contain any JavaScript, with eval could turn into executable code. And this is also something that is having a big impact on which of the sites, which of the JavaScripts I actually can use this technology. Yes? That is enforced, yeah. But I will discuss, there's a way out to bootstrap the whole process. But in fact, you should go to a website where you actually, the JavaScript itself is actually having the code and the binding technology to bind that code to your HTML page itself.
So even if you specify script source equals self, so you allow scripts to learn from yourself, then having an inline script isn't that sort of the same as...
No, so I will discuss my example and I will come back to that question because I think it's a very good question in that respect. So I will first show, this is typically the normal code for people not separating JavaScript and HTML. You have here an anchor tag. Once you click, you run my script. Run my script is actually showing alert. Again, this is not the perfect example to convince your managers that JavaScript is evil, but for me it's the easiest way to actually show that something is going on. The problem here is that we have inline JavaScript in our page, so even between the script tag we are declaring our function, we're also having the call in the onClick handler. Where we have to go to is that we actually say we're including script from our own website, but we don't have any JavaScript being specified on this page apart from loading a JavaScript resource. And the code here down is again the same function declaration, and then you have some code of actually adding an event listener to content that is searched by MyLink. So indeed, if you're looking into this code, it's making it somewhat complexer than writing it in line. On the other hand, this should be abstracted actually by the tools you're using to develop your applications, and it might still take some time by tools to actually generate that code, but this should be much easier to say, well, if we have the code being set here, we can actually decide where the code should be allowed to run or not to run. If you see the spaghetti of all the code and the HTML being mixed, I think both of them have disadvantages.
Yeah, but if you go, so developers done that, we try to find solution to debug easily.
Yeah.
To debug easily to see directly what is linked with that division or
Yeah.
that thing. So if you put on click and you assign some JavaScript method, it's easier than to add listener because you don't have really
Yeah.
that link. You're stuck with the corresponding function that is added by the active listener.
I fully agree with you. So also I have seen discussions in the new standard of CSP where you would not be allowed to run any arbitrary JavaScript here, but that you only would be allowed to run without any parameter functions that are defined in your external file. And I think that might be a good compromise because you say, well, I specify clearly what is allowed to execute on my page, but I will still allow that people directly can say on where that event should be actually inserted. The moment, of course, that this is just any plain string in JavaScript and you can execute it, you still have the problem of cross-site scripting. But if you say only functions without any argument or any attribute, then I think it might be a good balance between usability and security. But for now, the standard doesn't specify, certainly not the 1.0. But I understand your concerns, and if I would be the one deciding, I probably would invest much more what are the security impacts of actually having that hybrid solution. So to come back to the question, to your question, what is self? So self means you're allowed to load JavaScript resources from your own site. It doesn't mean that you're allowed to run inline JavaScript. That's what self means. But of course, we have legacy applications. We have inline JavaScript. How do we handle that? So actually to bootstrap the whole process, to actually get some traction, you could use some insecure relaxations by, for instance, saying for scripts, use the unsafe inline directive to say, I temporarily allow scripts to be loaded, to be inlined in the page itself. It will tear down some power of CSP, but maybe a first way to start to get certain things being rolled out in the wild. Similarly, you can also say, well, for some of the pages I really need eval to be enabled on that page. Also there you can specify eval is enabled. It will still give you the opportunity to say, well, I'm actually sure that external JavaScript will not be loaded, but eval locally may happen. And similarly, we can also say the unsafe inlining of style sheets is allowed as well. But I really want to stress, this might harm the security and actually undermine the whole technology of CSP, so be very careful when actually using some of those relaxations. But I fully understand it's not that easy to refactor one application today to tomorrow, but it might be a good way already to slowly bootstrap certain of the CSP directives that are in here. One of the interesting features, so maybe before I go further on, does everyone understand well what's the concept of CSP? What is the idea of actually limiting the resources to be loaded? Okay, then one of the things I want to go in a little bit more detail in the presentation is actually the reporting feature. CSP has actually a very interesting feature that any violation to your policy can be reported back to the server owner. It means that you actually can see attacks happening in real life on your application because any violation that the browser sees is actually pushed back to a URL specified by the website owner. And there are two ways. You see the actual violations happening on the client side. With most of the technologies that we have right now, we don't know what's happening on the client side. We only see some server-side logs. Secondly, it also allows you to fine-tune your policy. And we'll discuss a few examples later on. But now you know that certain pages are not rendering as you expected because they're including stuff from Google Analytics. One of the developers did push it in. It's not harmful for your website because you wanted to have that, but you didn't think about it when writing the policy. Well, at least now you will have a sign back to your server saying this is needed to actually load my full page. How do you do it? Well, as part of the CSP header, you just say my report URI is a certain URL. It can be local, but also after some discussions on the mailing list, it's also allowed to actually send it to a different origin. So you could say I have a third-party service actually getting all my reports in and delivering some service to me as well. And how it works is actually it will post a violation report to that URL. So that URL should actually have a handler to accept JSON coming in and actually storing it somewhere on the server or processing it somewhere on the server. Let's look to one of the examples of such a violation report. So we have here a very simple content security policy, and by now everyone should be able to read the first line. But I will help you a little. Oh, maybe we can try it. What does the first line mean? Anyone?
You can only load scripts from your own page and from the APIs that Google come.
Indeed. And what does it mean for other resources? Because we didn't discuss, other resources are not disallowed by default. If there would have been a default source none, all other resources would have been blocked. So it's actually an enabler, so you can step by step specify your policy rather than saying everything is blocked and I now have to specify everything on my website. The report URI goes to thisexample.org, which has a good report parser. What it's actually doing, and this is based on an example of my quest, which is available on HTML5 Rocks website discussing how you actually can apply your CSP directives. Here you see in the report itself, it says what was the original policy, so you know which policy was actually applied on the website being rendered in the browser. You see which directive was actually triggering the violation. You see which document was loading. If there's some information about the referrer, you also give it as part of your violation report, and you say, actually I blocked this being part as a resource in my page. This evil.example.com was not specified in the script source, and I blocked this to being loaded in my website. So this is very interesting to see if something malicious is happening on your server. Suddenly you start to see that someone is trying, cross-site scripting, is trying to load external resources into your page. Interesting to fine-tune, interesting to see real-time attacks. It's actually even becoming one step further even more interesting with the reporting feature. So apart from reporting the violations from a policy being enforced in the browser, you could also run CSP in a report-only mode. What does it mean? You can actually specify the whole policy you want to enforce on your website, but you have actually a beta testing. What you do is you report violations back to your server, but you are not enforcing the policy. So the resources are still loaded, so that the user doesn't notice anything what's happening in his browser, but at least you know for your page how well your policy is actually suited to support the policies that you want to enforce on that page. And this is the first step you do. You run it in report only, you see how well your website behaves, what are the information, the violations coming in, false positives, false negatives, and then you can go one step further by actually enforcing it in real time in your browser. So I think the whole step of reporting and being in report-only mode is a very, very interesting thought of actually being deployed in new systems, on legacy systems, on systems in the wild, where you can actually have different steps before you're actually blocking content in the user's browser. So does everyone understand those concepts and reporting concepts? Tom?
Would it be possible for an attacker to forge his own reports? So like some thousands of fake reports?
Certainly it will be possible, yes. Because it's just a normal URL you post, you could post anything. And that's something they have no means by now to actually protect. You could think of that you're using, for instance, information in the URLs that you're having some kind of token, which is actually specifying from where you're coming. You could think about referrer. You could also say, even in the policy itself, you could include that, for instance, apart from this domains, you also include one subdomain which actually contains a token to make sure that only the items you send to certain domains are being reported back. A little bit similar like cross-site request forgery tokens are happening. But I didn't have any thoughts on how to protect or how to, that are actually being discussed by the committees proposing CSP. But I think it's a very interesting thought because indeed what would be hell if you actually have kind of a lock on your server and that you can't trust the lock coming in. And denial of service, or you have like 20,000 things being locked and one is actually the real attack, so it's very hard to distinguish. I think you absolutely correctly. I think also the people that intended report only, report mode, mainly had in thought to actually do the report only mode as bootstrapping mechanism, or if you are changing your pages or enforcing new policies to see what's happening on the client side, rather than real-time monitoring what's happening on the client side. But that's a very correct observation. Alec?
Is the content security policy specification itself can be a possible target of an attack? So that's protected by TLS only? Or? Because you send it as a header, like okay, I can imagine if as an attacker.
So if you're sending it over an encrypted channel, the integrity is preserved. If you send it over an encrypted channel, it's much easier to actually adapt the page itself than adapting the header. But you're true that. Also I think people using CSP already took all the previous steps before they continue to CSP. Also I don't think, and I want to really state that clearly, this shouldn't replace all the mechanisms you have in place to protect against cross-site scripting. It's just an additional layer. If you missed one thing, and actually the coding guidelines in your company or external software that you are loading, you have a better way of actually being protected on the client side. That's the only thing that they want to achieve. They don't want to say you don't have to do output encoding anymore, you don't have to do any output validation anymore. That's certainly not the case. So a few examples just to get a little bit exercised in reading CSP, understanding what is the power of CSP, and then we'll continue to the next topic. So the first one is mybank.net. It wants to lock down what resources are included in the bank. Again, those are examples based on my Quest interesting report on HTML5 rocks. So one of the policies could be, well, we want to load scripts, images and style sheets all via our content distribution network. So that CDN may actually provide us a lot of content. It's owned by us. We actually trust it, so we are able to load that. We need to make XHR request, but we only allow it to the API that our bank is providing via api.mybank.com. Third, we want to include iframes on certain pages. That might be advertisements, that might be, for instance, certain subsets of pages that we want to load in our website, but only if they are coming from our own website. All the rest of the iframes will be denied by default. And I think a good exercise, we don't want to have any 0 days by flash of Java. We don't allow any of those in our website. Well, if you would actually transfer that to a content security policy, so one thing I want to say, this is all one line in your header. I just broke it down in different lines with character return to make it a little bit more visible. But you will see the policies are becoming bigger and bigger anytime you want to add additional knowledge to your policy. The reason that I want to push it all as part of the header and not as a separate policy file is that they actually want to make sure that you only need one response and you don't need to fetch additional resources before you can actually load the page. So there was a whole long debate on the mailing list. Do we want to have policies externalized of being part of response itself? But it turned out that they wanted to push the policy as part of response itself. So here you see the default. We don't load any content that was not specified in our policy. We load everything from our CDN in those 3 lines. We are allowed to XHR to our API, and frames are only allowed from ourselves. So this is the basic policy of explaining those rules up on the top of the slide. A second example, are we able to actually make sure that our website is only including HTTPS content? And for people having an SSL certificate, for instance with extended validation, it's important to actually make sure that they load only HTTPS resources, because that actually will otherwise reflect in the way SSL statement is reflected in the header bar of your browser. It will say you're loading unprotected content. There might be a good reason to say I only load HTTPS content. Certainly scripts, you want to load JavaScript only over HTTPS, and we can discuss that later on during the break. How would that policy look like? Well, you say the default policy is the default source, only the scheme HTTPS can be used. In case that you are overriding directives, the whole default is forgotten, so you need to replace it in any relaxation with unsafe inline for styles and scripts as well. So if you forget this, the scripts and the styles would still be allowed over HTTP. So this could be a policy that you can deploy at this moment without adapting any of your website. Style sheets are still inline, scripts are still allowed inline, but by default you get the opportunity that you can block HTTP, that you only use HTTPS in all your resources. If you add one additional line saying I don't want to use Flash or Java, you might have already a very good default protection mechanism on your website without changing any code.
This would still allow an attacker to load third-party resources as long as they are HTTPS resources.
Yes, indeed. But it would make sure that, for instance, your JavaScript itself will never go unprotected over the wire. So this is only an example, certainly not the final step of protecting your website, but it gives you just a few ideas of how you can use the CSP mode. And then we have a lot of websites having social media integration. Google Plus has scripts and iframes, Facebook has an iframe, Twitter has a script and an iframe. So if you want that all to be included in your website, well, you need to add quite some content to your content security policy. I think by now everyone understands how this mechanism of CSP works. I won't go deeper in detail on explaining the policy. Just to give you a flavor, Facebook is not adopting CSP yet on all their pages, but in the crawls that we did, we found one response of Facebook coming back with the CSP header, so they're actually experimenting with CSP, and this was already the whole policy that was sent with one page of Facebook. And you see it's growing quite fast if you need content from multiple pages. Interesting, so they're discussing which scripts are allowed to be loaded and to which websites they are allowed to connect with XHR. Maybe also interesting to show on this slide is, you see here Chrome extension. So it means that for Chrome, they're also allowing Skype to load additional resources on their page because this is a Skype extension. This has been discussed as well in the CSP community. The next version of the implementation in the browsers should allow any extension to adapt your page, because a lot of extensions, even extensions that protect your website, need to adapt your page or inline some script in the page. So in the future, this line should not be necessary to protect your website.
So the default source asterisk, is
yeah.
that sort of, so at the top,
yeah.
doesn't that sort of defeat, I mean, doesn't that say like, for anything I'm not specifying anything?
Yeah, well, if they would leave out the first line, it would be the same.
Okay, so, yeah, so that's...
Yeah. But they're explicitly saying it. I also think it's the first experiment. Typically what Gmail and Facebook and others are doing is actually trying certain things out on a very specific subset of their users to see how they are reacting. And I think I might have removed the report URI, so probably they're also seeing what that gives up as reports in the violations, just to give an idea of is it feasible or not feasible. But we were just surprised by seeing this, because any other page that we were visiting with Facebook, we didn't see any CSP header anymore. So it was really a snapshot. If it didn't have captured that, we wouldn't even have known that they were testing with CSP.
So if I understand correctly, the CSP is most effective if you sort of use it as a whitelisting approach to really specify only the things, and then you better set that default source to none.
Yeah, indeed.
That's sort of, then it's a really whitelist.
Yeah, indeed. And it's debatable if you, for instance, for video and audio, you could question yourself, do I really want to say which audio video is allowed or not allowed? What I also see in my experience in the use of CSP, and I will discuss it later on also with who is actually adopting it, people are also using those attributes to protect their IP. So YouTube wants to have that you visit the YouTube pages to visit their content, and that no one else is actually visiting it. And also that is something that is interesting to see, that also there might be some interesting thoughts as well. Well, just a little side note, we all know that JavaScript is everywhere. If you're looking to one website of the standard local newspaper, you see already some visible things like advertisements, social media being included. But behind the scenes there's a lot of JavaScript doing tracking, analytics, and a lot more. There's a whole bunch of JavaScript you can include on your website. And we saw in an experiment that more than 80% of the top 10,000 websites are using at least one remote source, and mostly they're actually using Google Analytics. But if you want to know anything more about that, just visit the talk of Steven and Nick, the last of this evening. They're actually having a whole experiment, actually visiting websites, seeing which resources they are including, and they also have a kind of neat attacks to attack the way people are including JavaScript. So I don't want to say anything more than that. Just if you have control over one of those JavaScripts, you just own the website. And I think everyone by now knows that this is the case. So let's focus on the state of practice. There are two browsers supporting currently CSP, namely Firefox and Chrome. We also see in the wild that we had previously all the header names, like the X, which means experimental, for WebKit prefix for the Chrome version. We also have X content security policy, but I think 1-2 weeks ago we had the final draft, so now you can just call the header content security policy, and also the browsers are adapted to take the header name content security policy rather than being prefixed. When we did an experiment on the top 100 websites, we only found that Dropbox was sending out CSP headers. So you see it's still an early stage of adaptation. People will be using it probably much more in the next few years, but for now only a handful of websites are issuing the CSP. And I think similarly to Facebook, probably a lot of websites are very temporarily trying out certain things on CSP and disabling it again just to make sure that they are not breaking anything on their website. So a very small recap on what we saw about script injection, what we saw about attacks. We had the HTTP only flag, we had default behavior in the browser against reflected cross-site scripting, and a very interesting way of actually using the content security policy as an additional line of defense. The last topic I want to discuss in this session is how to use framing, and I will actually visit two things. Clickjacking, and I will only focus in a very small bit on clickjacking because it was already mentioned by Jim twice. But I also will discuss same domain cross-site scripting. So the name is not correct. What I mean with this is actually we saw a good way of actually using frames to actually remote content can be isolated in its own security context. But what happens if the security context is the same because you're actually loading unsafe resources from your own domain? And we focus on the HTML5 sandbox attribute to actually protect against that. So clickjacking, you just show an additional frame in front of the other one. The user doesn't see it because it's transparent and you're actually clicking on the wrong thing. Any countermeasure that was specified previously written in JavaScript or using all kind of neat techniques as a developer to defeat that by actually navigating your own page and things like that, well, they are broken. You can disable them by disabling scripts and using sandboxing techniques. You have the frame navigation policies actually making sure that you can't navigate the top level domain. You have certain techniques even being protected by the cross-site scripting filters, protecting against reflected cross-site scripting. So it's very hard to actually see what is the way to protect. And there's an interesting paper, Busting Frame Busting, studying the whole experiment of clickjacking and all seeing all the different ways that are actually broken to protect against clickjacking. But the good news is there's X-frame options. Again, it's a response header. With X-frame options you say which domains are allowed to frame your content, and you have three options to say, well, you could say deny, nobody can frame me. You could say same origin, which means your origin can frame but others can't. And you also have the allow origin, allow from, where you can specify certain origins are allowed to frame me. The browser compatibility is Firefox, Internet Explorer and Opera all support this feature fully. Safari and Chrome do not support the allow from, but they do support the deny and the same origin. Again, almost half of the websites are protecting themselves, and I think it's a very, very good countermeasure. If you have stateful operations on your server, just issue an additional header saying you only allow it from the same origin to be framed, or certain websites don't need to be framed, and you're protected against clickjacking. Very short. There's much more information in the paper. I don't have the time to go any deeper on that. What is important here is, what's important in framing in general, we saw frames being used as separation contexts, but if you have content from the same origin coming, they're running in the same execution context. So even if you're using an iframe for them, they just will be able to walk to the other DOM, change, even remove the iframe, so they actually have full power over the whole website. So it's very hard to isolate content coming from the same origin. And for that, we have the HTML5 sandbox attribute. What does this HTML5 sandbox attribute do? Well, it actually enables the same origin policy even for content coming from the same page. You can use it without any value, then it's the default behavior, but you have also ways of actually making it more fine-grained. So the level of protection, you have very coarse-grained sandboxing, you have the same origin policy within the same domain, and this is the basic set of sandboxing JavaScript. Much more advanced ways of sandboxing JavaScript are discussed in the talk of Steven and Nick this evening. So what is the default of the sandbox attribute in HTML5? Well, you disable plugins and you run frames in a unique origin, which means for each of the frames having the sandbox attribute, they will generate a unique origin, and actually that unique origin has its own execution context, which means if you have content from the same domain and you have 3 different iframes with the sandbox attribute, you will have 3 unique origins running in your browser. They are not able to see any of the origin itself. They are not able to communicate unless you specify it. So they're really bound to something that you uniquely create and cannot be duplicated. Also, by default, scripts are disallowed to execute in such a sandbox. You are not allowed to submit any form or push any form button. You can't navigate top-level context, and pop-ups are blocked. You don't have access to raw mouse movements. So you actually have a very confined environment. You can't do much in such a sandbox environment. Of course, you could do some relaxations to say, well, I allow scripts to be running. I allow to have pop-ups, for instance, so you can actually fine-tune what the sandbox environment can do. But please be careful. If you combine some of the relaxations, you could just actually mitigate the whole technique of sandboxing. So for instance, if you combine allow scripts and allow it to run in the same origin, well, you can just walk up the DOM and just remove the sandbox attribute or adding additional content. So be very careful if you do the relaxations. I think the default relaxation should be allow scripts, because you allow scripts to run, but they are running in a different context, so they can't harm your website. I think that's the main idea of sandboxing. And one thing you can't relax is plugins. Any sandbox environment doesn't run any plugins. I think that's also a quite good behavior by default. So, and I think I'm closing to the end of the presentation, so I really want to show you an additional step, namely how some of the technologies I discussed today are just the basic building blocks, because what's interesting in developing applications is actually using those building blocks to have a more security architecture for your web application. And this is where, for instance, CSP and HTML5 combined can play a very interesting role. So one of those architectures is again presented by Mike West at DevOps 2012, and they're actually using this technology to confine certain unsafe functionality in their repositories like Google Docs, where they want to allow scripts to be executed, but they want to confine it via those architectures. So how does such a security architecture look like? Well, you start with your main site. Your main site wants to protect itself of untrusted executions. What does the security architecture do? The first step is you create a sandbox JavaScript execution environment. And then you actually have web messaging allowing communication between the main site and the sandbox environment in a very controlled way. And how does the security policy actually apply on those topics? Well, the first side, the main site, you protect it with CSP, which means you're not allowed to run any inline JavaScript on that website part. On the main site, you're not allowed to run any inline JavaScript. What you are allowed is to delegate all the executions towards the sandbox environment. The sandbox doesn't have any restriction in executing JavaScript, but it doesn't have any access to the data being protected in your main site. It doesn't have access to your cookies, to your local storage. It can't issue as being from that domain. It's really in a confined environment. But it allows to run JavaScript in its unique origin. And by delegating back and forward between the main site and the sandbox environment, you can create a quite interesting security architecture. So let's look how this would be actually implemented, and then you will understand what I mean by the interesting features. You have your main website, which actually loading a JavaScript main.js. We're having an iframe being the sandboxed frame. It's allowed to run scripts, and it's sandboxed. So it means it runs in a unique origin, but still you can run JavaScript. and we want to actually use some JavaScript that is not safe. We know it's from third parties, it might do any harm, but the resulting string we would like to display to the end user. So we would like to display some content in this div element on our web page. So this is the main setup. We want to execute something, we can't trust what's going on. It could read our cookies, send out whatever it wants, but we want to execute it without having impact on our own security, but then the results should be displayed on our website. And pure HTML, no execution, that's the idea. And the fact that we don't execute anything is actually enabled because we have the content security policy. We can load main.js, but we can't inline any JavaScript later on in the process. So the main.js, what does it do? Well, on clicking the event handler on the previous page, so we had an event handler that we want to bind to the click here button, but this shouldn't be sandbox frame, this should be click. Then what we do is actually we click the event listener, and then we say once you have a click, we contact the sandbox frame, and we will actually do web messaging via post message and sending the command we want to execute in the unsafe execution environment and the data that it might have to be used, that might have used. So we provide them some content, only a subset of the data that we have on our website, but that data can go to the untrusted environment. It does some execution on that and gives us back a result. And that's the second thing. When we get back results from that insecure frame, we just take the content element on your page and push that HTML to that. So all the results coming back from the content will actually be inserted on our page. And then we have the sandbox frame itself. It can run all the execution at once, so it gets an event handler getting data coming in. We see a command, we see context, we execute, and the only thing is the end result is pushed back to the main site. Even if there would be a script in that string that we are pushing to the main site, because the CSP policy says no inline script, we only will render that attack uses, we only will render the pure HTML on our main website. So it's a basic idea. I don't think it's the definite security architecture we want to go for, but it shows that the building blocks themselves can be combined in a very interesting way. And Nick and Steve will discuss much more about sandboxing JavaScript. So I had something more about the next steps of sandboxing, but you can read it on the slides, and I think it's important to go to the conclusion. So maybe one interesting statistic, we did an experiment how many websites use sandbox in the top 100. None of them are using the sandbox attribute, although 4 of the browsers are actually implementing the sandbox in their behavior. Okay, so wrap up the conclusion. We saw in this presentation a whole range of new security features. All of them have the same pattern. You have browser-side enforcement, but you have the server being in control of the policy. It's certainly not a replacement of your secure guiding and secure development, but might be an interesting additional line of defense for both legacy applications and newly deployed applications. And I think there's much more to come. I expect to have many more features in version 1.1, 1.2 in CSP, and you will see much more of those techniques coming up because they have a really powerful enforcement near to the client-side execution environment. And with that information, I would like to thank some of our sponsors in project context, and I have also a full list of references if you want to read more, also seeing some of the presentations going a little bit deeper on one of those topics. And that's the end. If you have any question, please feel free to ask. No questions anymore?
So CSP is not standardized yet? So when is it?
I think version 1.0 is standardized, but they're continuing version 1.1, 1.2 and so on. So it's a very active community. It's mainly driven by Adam Bart, which is actually pushing it very hard to get it implemented. Also because he's one of the Chrome developers. Anything being discussed almost the next day, next week, it's actually having a proof of concept in the Chrome Canary version. So it's really having a lot of interaction, a lot of traction there as well in the community.
You know, is there something like a graphical user interface for defining CSP policies? Because it looks like the requirements are
Not yet. I'm not aware of any. I saw some research actually trying to extract your CSP policy from your website itself. So it's actually scanning your whole code base and saying what would be a good policy. Also some of the refactorings to externalize JavaScript. But to be honest, most papers I read on that topic, or only the first initial step, and would probably not be practical on your larger websites. But I think there are much more to come. Once that information is there, you know what are the benefits, people will jump on that. There's certainly a benefit there. I see similar, a good benefit in actually providing the whole infrastructure of handling the reports and actually filtering out which are interesting violations. Also there is a whole community or possibility to add new technologies in place.
I guess the first step would have to also be what framework to start.
Yep, indeed.
In a kind of transparent, but you know, it shouldn't be too difficult to specify that.
So for instance, one of the things there is if you have multi-tier languages like Google Web Toolkit or others, if you're actually having it already in a meta language that you say, I want to include an external resource, then it would be very easy that page is also compiling to what's saying, well, I also will issue a CSP header. So there might be some advantages depending on your framework, on the level of abstraction you have there, to actually extract that information. For people writing the code manually in PHP, I think it's cumbersome to actually achieve this level of protection. But I think also there we will see a new trend in actually how you program your websites and a little bit more abstraction. Okay, thank you very much for listening.